All right, so we're going to look at the first part of section 1.3. And what we're getting into is, well, how do we actually go about collecting sample data? We've talked about a lot of things that could go wrong. For example, again, the survey where you say, who else to fill out this survey? Come fill it out. It's about putting a new park in town. And so the responses you're going to get are people who feel strongly about this, and people who maybe don't, or they're embarrassed to answer. They might not want to give an answer, and as a result, well, the survey might not really reflect everybody's views on this new park. So we're going to look at some ways people collect data, and we're going to really go after this thing called a simple random sample. That's sort of our really what we would like to get if we can, but even that you sometimes have to approach in stages, and we'll talk about in the second part, the second lecture for this chapter, or this section rather. But first off, this section, we're collecting sample data. So what we're looking for are appropriate methods. What would be an appropriate method? Well, we need to choose one. If we don't, if it's not appropriate, then our sample could cause misleading results. And again, thinking back to that survey about parks, if we don't account for people who are not responding, if we can't represent their point of view, we don't necessarily have an accurate point of view of what everybody in town thinks about this park. So we're going to look at some basic design ideas, concepts that we want to keep in mind when we go out to put together some kind of experiment or some kind of study, things we want to kind of, in a sense, aim for. So, basic design. So, things you want to keep in mind is two treatment groups, or two groups rather, not necessarily treatment. Now, this is going to be for an experiment. And when we do an experiment, now this is different from an observational study, but for an experiment, we want to see if, say, some particular drug makes a difference in, well, getting rid of flu symptoms. So we want one treatment group and of course they receive the treatment. And then we have a placebo group. And in theory, the placebo is going to be something that doesn't have any effect. The classic example of this if you're testing, say again, some kind of drug, let's say it's a pill. One group of people will receive a pill that's the treatment. The other group, they might think they're getting the treatment, but really they're getting a sugar pill instead. And so what we want to do is we want to study whether or not this treatment works. Now, there's something to keep in mind, and some of you might be thinking about this. Well, they think they're getting a treatment. They don't know they're getting a sugar pill. And you might have heard of something called the placebo effect. And it's this idea that if you think you're getting a treatment, you may think you're getting better. Now, whether you are getting better, whether you just feel like you're getting better, well, who knows? This is sort of expected. And here's the thing. With the placebo group, perhaps there is some random chance that some people do get better with a sugar pill. Or they have kind of a mind over matter kind of thing that, well, that positive influx, that positive encouragement that taking a pill has, maybe it causes the body to mend itself, that positivity, who knows? But this is kind of expected to some extent. It's part of the randomness of life that sometimes you'll get better because you think things are just better. You got a treatment pill, feels great. Now, what we want to see is, does this group that really does have a treatment, can they outperform the randomness of placebos? If this drug really works, it's going to make everybody, or at least enough people, to improve more so than the effect we get from the positive input. In other words, this drug is changing things. And that's what we're looking for. Can we basically outdo the placebo effect? So one group is going to get a treatment. One group is thinking they're getting a treatment. They're getting a placebo. And basically what we're looking for does treatment group outperform placebo group? And then we're going to add to this significantly. Does it outperform it significantly? Because let's say the treatment really doesn't make any difference. It's no different than giving somebody a sugar pill. Well, if you have basically, it's like a second placebo group then. So you have two placebo groups, and randomly one placebo group might outperform another one by a little bit. Maybe 10 people don't have symptoms and versus 8 people who don't have symptoms out of groups of 100. Well, 10, 8, is that a significant difference? Not really. It depends on what you're looking at. So we want to see if the treatment group outperforms the placebo group. Oh, let me put the word group here. Does the treatment group outperform the placebo group significantly? And that's going to mean that this drug is making a difference. We're not just seeing people randomly improving, and they can improve randomly for different reasons. No, the drug's actually kind of pushing people in a direction where they are not having symptoms for flu anymore. A lot of people are being affected in that way. So that's the idea of a treatment group versus a placebo group. All right. Now, there's an example they give in here, and it's what they call the gold standard. And this is a study, it was done in 1954, well, to see if the new polio vaccine was working. Now, polio was something that you would catch. It was, and you would basically usually go into a state of maybe long but still temporary paralysis for the most part, though sometimes you could get it for life. they wanted to come up with a vaccine for this. So the way they did it, and this is a key thing here, when we choose who's in the treatment group and who's in the placebo group, we randomly assign subjects to treatment and placebo groups. We want to make sure we do this randomly. Like maybe you use social security numbers. Maybe you give everybody, going back to our flu study, at a group of 100 and a group of 100, give everybody a number from 1 to 200. And you randomly pick 100 people to be in one group, randomly pick another 100 people to be in the other group. Well, if you pick 100 from one group, those left will be in the others. So other group. So the idea is you want to assign treatment group, placebo group membership randomly. So what they did here, go into this study a little bit. So this is 1954, and we're studying the Salk polio vaccine. Now, this is what they did, and there's the groups aren't the same size, and they say, guess for this study that was good enough. But what we had, there were 401,974 children randomly assigned to treatment or placebo groups. That's a lot of subjects. So over 400,000 children were, now I'm not sure how they selected the 400,000 children. We're going to get into some of that later. But once they've been selected, they had to be broken up into two groups. And so this is what we got. $200,745 received the Salk vaccine. So this is your treatment group. $201,229 injected with a placebo. Now, what would that be? Like, okay, this is a vaccine. What's not a vaccine? And oftentimes I don't know the study well enough to say what the placebo was. But if you ever take like maybe nursing classes or EMS classes, what you'll find, usually when you do practice injections, you're using saline solution. So that could have been it, maybe, but I don't know why. You have to look that up. Anyway, the thing is they were assigned randomly. And according to the text, and we've mentioned this already, like a coin flip. So you could do something, you have a list of subjects in this study and you have this person and you flip a coin, and if it's heads, this person goes into treatment group. If it's tails, they go into the placebo group. Now they said it was like a coin flip. I don't know if that's exactly what they did. There are some controversies with how you assign things randomly. Computers, sometimes you try to generate random numbers with computers. There are arguments that there's no such thing really as a random number from a computer, at least using current technologies. And there's been some other issues with this. There's a famous controversy from the days of the Vietnam War during the draft, whether or not when people were randomly selected to, well, go into the military and go to Vietnam. And there was some controversy whether people were being selected truly at random. And again, whether we're using machines or devices to do this, we want to be kind of careful. Even a coin flip, does the coin in some way get damaged if you flip it enough times that maybe it's heavier on one side than the other? Who knows? So coming up with random devices, things that assign things randomly, might be kind of tricky. So anyway, just to be aware of that. So what happened? What occurred here? Well, these are the results. Now, I'm not sure. I don't think they were giving children polio on purpose, as far as I know. I don't know this. Again, we'll have to look up this study. But this is what came out. In the end, 33 from the Salk group got polio. So for all that we know, maybe the children received the injections and they went home, and then over the months, you would say there's some period of time where you were going to do this study, and over that period of time, how many people got polio, how many didn't, or what did we see? Well, 33 children from the Salk group, and then from the non-Salk group, 115 from the placebo. So 33 children who had the vaccine still got polio, but 115 who received the placebo got polio. Now, if we look at the numbers here, the group that got the vaccine is smaller than the group that got the placebo. So one of the questions you might ask is, well, this is a smaller group than this one, so if everyone's, say, equally likely, doesn't really matter. Let's say the treatment doesn't work, and really the odds are the same for anyone in either group to get polio. Well, if this was 200,000, you would see maybe, say, 100 here and 100 here got polio. Since this group is smaller and this is larger, well, number of children who get polio will be smaller than the number of children who get polio in this group, and because this group is bigger. Now, so that would kind of make sense, but 33 and 115, that's a pretty sizable difference. 200,000, 201,000, this is almost 201,000, and this one's a bit over 201,000, but not up to 500 here. So you could kind of say this does seem to suggest maybe this is having an impact. So we'll talk about that later. How do you know this is making a difference? We'll get into that with hypothesis testing. But anyway, those are the results from that study. So there are some issues here with experiments. Because the question that I had, and again, I'd have to look this up, they weren't really giving children polio on purpose. I hope that's, ugh. So that brings up an issue with experiments. This comes up if you ever do, say, if you sign up to be a test subject, especially if you transfer to a four-year school where they're doing research, you will have opportunities to become a test subject for graduate students and some possible professors. And one of the things that they have to do is make sure the study they're doing is ethical. Like, they're not doing something like giving you polio without you knowing it or something like that. So there are certain experiments, they might not be approved. So there could be ethical reasons. I would imagine experiments that involved near mortal combat probably would not be approved by an ethics committee at a university, at least as far as I know. So there are some things you might want to study that might not be possible. Now, there are ways to sort of deal with that. And this can also be controversial too. You can look at maybe, well, past data, like say there was at some point, say someone was exploring Mortal Kombat. People are fighting over something. Do people harm each other more in combat if they're fighting over status or fighting over relationships, something like that? And I really don't think you're going to get an experiment like that approved by an ethics board. But you might know that maybe in the past somebody did do that. They conducted that experiment like in 1910 or 1894. And someone took groups of people and they had some way of measuring physical damage. Well, this sounds like a horrible study. And they had them fight over relationships, whatever that's going to mean. They had to fight over status, however you measure that. And you look at the different injuries people had and which group got more injured, the people fighting over relationships or people fighting over status. And so you could go back to past data and try to draw conclusions from that. You do have to be careful though. Even past studies could be controversial to bring in, especially if the subjects, if the conduct of the researchers was not appropriate at all. For example, tricking people to maybe take poisoned food and they don't know they're taking poisoned food. Things like this. Even past studies, quote unquote, might not be acceptable to bring into your current work, or it could be very controversial to do so. So you got to be very careful with that. Just because it was done in the past, and it does not mean you're going to be able to bring it in today, and it might not even make it okay. And there's a whole large conversation that could be had about that. So there's ethical reasons to keep in mind. See, other things that are going to be a little more mundane, but certainly realistic, costs. If you're going to do a test like this polio study, you got to come up with a lot of vaccines. I think they had, just over 200,000 subjects, 200,000 children in this study. That means you got to come up with 200,000, doses of this medicine and probably a whole bunch of, syringes that you can use. There's cleaning equipment for these things. There's staff you need to hire to actually administer the injections. Same thing for the group that's receiving, say, saline solution. Again, staff, cleaning utensils, things like that, the saline solution itself. Then you got to track everybody. There's going to be correspondence. In those days, you're probably using some kind of letter system. You might be mailing each other. Maybe you're having someone drive over to a doctor's office and to say, well, this is how we're doing, test them for polio. In our time, what you could have here is email communications. And you got to pay someone to send and receive those emails. The cost can get up there pretty quickly. So that's another thing that might change your experiment, or it might not be possible to do it. Time, of course, Is there time to do this? Usually there's a limit to how much time you can conduct an experiment. And there are some that are quite long. We'll talk about observational studies later. There's a very famous one that's I think it's still maybe being conducted, maybe not. We're getting kind of close to almost a century since this started. It was a questionnaire that was handed to Harvard graduates who graduated in the 1930s, I think. And the question was basic questions like, are you happy? Do you enjoy life? Are you optimistic? Are you pessimistic? You're not enjoying life. And they asked graduates from like maybe one graduating class, maybe more, I'm not sure, just to keep in touch. We want to ask you this question now that you graduated from college throughout the rest of your life. And people living to their 80s, 90s, possibly longer, I'm not sure. And some people stopped participating in this observational study, this survey, but some continued on. And they learned some interesting things about what makes people happy, what might not seem to make a difference really. It's an interesting study and something you might want to look into, do a Google search for that. But you need someone who's always going to be around to try to contact people and to receive surveys from people. And it's probably not the same person from the 1930s on. It's probably been passed on to different people. So, okay, in that case, you could have a very long observational study, but usually with these, there's a limit on time. You might have maybe a week, you might have 6 months. There's going to be some time limit to keep in mind. All right. And there are other reasons, other things can come up. So just to throw that in there. So there is the possibility of using past data. And again, this could be very controversial. So it depends on how that data was collected. It's something that just because it was in the past doesn't necessarily make it okay. There could be some issues with that. So just pointing that out. All right. So a little bit of terminology. In general, with an experiment, what we're going to do is we're going to try to see if we can change the world, basically. A treatment is applied. So this is how we're going to try to change the world. And as a result, effects, if any, observed. So we're going to take our world, add something new to it, and see what happens. That's basically an experiment. Now, individuals, and this is a very broad term, individual. This could be inanimate objects, it could be human beings, it could be animals. Individuals in the experiment are called experimental units. So individuals in an experiment are called experimental units. Now we do make a caveat. If these are people, well, we don't call them experimental units, we call them subjects. So, and again, experiments, they're not just limited to people. They could be working with, say, objects. You could be testing whether or not a product is, well, without defects. You could be doing a random sample, what they call quality control. Random sample of, say, I don't know, well, watches. A random sample of watches, and you just try to see how many in this random sample are maybe defective. You could be, this is sort of a, kind of an observational experiment of sorts. It's really an experiment. So this is more of an observational study, quality control. But then you might do an experiment. You might try to change things. You might say, well, let's say I take a random sample of watches that claim to be waterproof and dunk them in water. Let's add water to this and we'll see how many are still functioning. So those would be experimental units, those watches. But if we're dealing with people, if we're giving out some sort of flu drug, we refer to people as, well, subjects. All right. So we have an experiment. This is where we add something to the world and we see if it changes. What are the effects? Then we have what's called an observational study. All right. Key thing here, we observe and measure specific characteristics. Now, to be fair, in an experiment, we're going to do the same thing, but with an experiment, we've done something to change the environment. And then we're going to see how that might have changed some characteristics. Observational study is different. In this case, when we measure the characteristics, no changes were made beforehand. We don't attempt to modify anything. Now you got to be careful with this because you can argue that if you approach somebody with a survey, just by you being there and say, hey, I want your opinion, that might modify the subject. So that becomes, controversial. You might have seen this with that potato question in the homework, where they say the Idaho potato group wants to know what your favorite vegetable is. Now, if you think of all the vegetables, there's cabbages, there's carrots, there's onions, there's celery, there's potatoes. So of all the vegetables we think of, would potatoes be your favorite? How often would that be? And with this, if the Idaho potato group comes up and they say, hey, we want to ask a question, it is clear they're representing the Idaho potato group. People might say, oh, well, it'd be nice to tell the Idaho potato group that my favorite food is potatoes. So you could accidentally modify things without meaning to. So Observational studies could be kind of tricky, depending on what you're trying to do. Now, we're going to take a look at something that could be an issue with observational studies, and hopefully with experiments you can minimize. Lurking variables. So these can affect subjects without the researchers knowing. They can affect subjects without the researchers knowing. And again, this is kind of like that Idaho potato survey. If you don't realize that having that t-shirt on or having that letterhead that says Idaho Potato Group on the top of your survey, you might not realize that that might be influencing your subjects to say, oh, I want to tell the Idaho Potato Group that of all the vegetables out there, celery, carrots, jalapenos, I think jalapenos are vegetables, my favorite's potatoes. So that could be a lurking variable for some researchers. They might not realize that having Idaho Potato Group written on top of the survey or having the t-shirt on might be influencing their subjects. So lurking variables, these can come up in observational studies a lot. So you might not be able to control these variables. Now there's some things you can do, like for example, for the Idaho Potato Group, they could make sure that their volunteers are not wearing any t-shirts that say, I'm from the Idaho Potato Group. Use a survey that doesn't have letterhead that says we're from the Idaho Potato Group. And as long as that's acceptable, you can conduct your survey. So there could be some things you could do. And again, you want to be careful in doing a survey for a particular reason. You know, there might be, again, some ethical issues if you don't actually say who you are. So again, you know, things to think about. So these variables could be things that we can't control because they're in the outside world. We're not trying to control anything. We're not modifying anything. We're just writing down what we see. And the outside world can have all kinds of influences surrounding our subjects. So we're kind of at their mercy to some degree, unless we come up with an experiment. We might be able to conduct an experiment that could get rid of these. So let me take a look here. So let's say we do this. We do an observational study. Abbreviate observational. And this is what we notice. Does ice cream cause drowning? Is this really a problem? And what we discover is this. We observe as ice cream consumption, we'll squeeze in consumption there, increases, so does the number of drownings. That's what we observe. Now, we think back to correlation and causation. Is this really a cause? Is ice cream causing people to more likely drown just by eating ice cream? For example, if I'm sitting on my couch, it's December, and I kind of feel like a bowl of ice cream. So I get some vanilla ice cream, get some of the hot chocolate, pour the sauce on there. It gets all hardened because of the cold ice cream, and I'm eating it, and I have to suddenly realize, because I'm doing this, I have increased the chance I could die of drowning, perhaps even in my own living room on that couch. Well, again, this is a causation correlation issue. There's a lurking variable here. And it's this. Seasonal temperatures. As the weather warms, what typically happens is people will go out and get ice cream. I don't know, I might get ice cream in December, sit on my couch and put the chocolate on there. But a lot of times people buy ice cream in the summertime outside. And that's usually happening in the summer. So in the summer, there may be an increase in ice cream sales. All right, well, fair enough. I mean, I think about snow cones, for example. I'm kind of a snow cone person. And the last time I bought snow cones, I think it's almost always been in the summertime, maybe late spring. But yeah, I can't really think of the last time I had a December snow cone. All right, fair enough. Maybe this is the case. And this might also be the case is that in the summer, more people go swimming. Now, I might argue this and say, well, hold on. I mean, people could go to indoor pools. But you could probably make an argument that people will go swimming in the places that maybe aren't as protected as an indoor pool, like a lake or a river, the ocean. I mean, there's going to be lifeguards in some of these places, but it's harder for them to get to you if you're in the middle of a lake versus in the middle of a swimming pool. So you could make the argument there's a lurking variable, seasonal temperatures, that when things warm up in the summertime, people get ice cream and they like to go swimming. So what do we do about this lurking variable? Well, and this again would be sort of a hazard of an observational study. Now, can we do something about the weather getting warm in the summertime? Well, no, we really can't. At least not yet. And should we? I'll let you think about that. There is something we could probably do. we can conduct an experiment. And so what we could do is this. We create a treatment group. We randomly select people to receive a lot of ice cream. And then we come up with a placebo group. Or we could call it a placebo group. We don't really necessarily need to do that here. We could just select another group randomly. And so we just watch the two groups. So this group here, we might drop off maybe a quart of ice cream to their house every day and just say, eat as much of this as you can. Maybe we do it maybe once every 3 days. I mean, if you do this every day, that's a lot of ice cream. You might get really tired of ice cream. So maybe once every 3 days, pop by their house, each person in this group, here's some ice cream. And maybe it's the same ice cream, their favorite. In this group, we just say, you're in the group. And we're not going to give you any extra ice cream. We're just do your thing. Maybe we don't tell them why they're being picked. We just say, you're going to be in a study, and you're going to be picked in this group. And then that's it. Just live your life. And we'll be asking you, at the end of the week, just how you're doing. And we're going to ask specifically, well, clearly, if we get a hold of you, we just, did you drown? Well, I mean, if we get a hold of you, probably means you didn't. Then again, you got to be, does asking this question maybe affect them? Maybe they'll stay away from lakes more than they usually would. So maybe you ask the question. And again, this has to clear like an ethics committee. Are you okay? Did you have any accidents? Something like that. And, a question that would be, again, it clears your ethics committee. Anyway. But basically, that's what you're going to do. One group, you're just giving them ice cream, and end of the week, we're going to just, are you okay? Same thing with this group. We're just going to, except we're not giving them ice cream. We're just going to call up at the end of the week, see if they're doing okay. And then this is what we're going to do. Compare the drowning rates between the two groups. I admit it's a bit macabre. And so we'll try to see if there's a difference. So there we go. Now, if you're putting your critical thinking hat on here, you could argue that if you give this group too much ice cream, they might not want to go swimming as much. What they say, you're supposed to wait 30 minutes before you go into the water. Well, if you're eating all this ice cream all the time, you might say, I don't really want to go swimming. I've got ice cream at home. So this group might artificially have a lower rate just because the food is just drawing their attention away from the lake. Again, just thinking about holes in the experiment, things that could go wrong. Lurking variables, in other words. But this would be at least some way of getting around the temperature variable. You could do this in the summer, you could do this in the spring, the winter, or the fall, it might get rid of the temperature variable to some extent. I would argue you could do this, say, in the summer. And so the tendency to eat ice cream might be the same between the two groups, though if you're giving this group a lot more ice cream, they might not be going out buying it as much because they're getting it from you for free. So, does that confound our study a little bit? But let's say that it doesn't. Let's be idealistic here. And pick, say, the month of July, free ice cream, no ice cream, just do their thing. Are more people drowning in one group than the other? So that might mitigate the effect of the temperature. Maybe not completely, but maybe a bit. Anyway, all right. So that's the idea of lurking variables, and it's fun to try to figure out where lurking variables could be. Again, if you're eating all this ice cream, you might not want to go out to the lake as much. I mean, this ice cream's pretty cool, and I'm happy eating ice cream. I'm watching my favorite show on Netflix. Maybe I'd rather do this than go swimming, and maybe that's a significant lurking variable that maybe makes this study not valid. So again, something to think about. Are there lurking variables in the study, including experiments? All right. So designs of experiments. Key thing is what the text calls it. They call it replication of individual units or subjects. Another way of putting it usually this is the case. So more than one subject or unit. And to put it more, well, specifically, your sample size should be large enough I'm going to get the word here wrong. Or let me back up here. You want your sample size, if you're doing an experiment, again, let's think back to what an experiment is. Basically, you have two groups. One group gets some kind of treatment, other group gets a placebo, and we just see is there a significant change in the treatment group that appears that whatever we've done, it's happening, there are effects, there are consequences that are not random. There will be changes in this group too. That's just the randomness of life. But do we see changes here that are big enough in this treatment group where it doesn't look like the randomness of life, it looks like our treatment has made some kind of change. And we need to make sure our sample size is big enough. So when we're designing our experiment, we want enough subjects or individual units to be able to observe the effect. Well, what would happen if you just had a sample size of 1 and you give me the drug and I suddenly feel better? Well, isn't that good enough? Well, how do you know I'm not that one person that has that kind of placebo effect really working for me? where that kind of, maybe it's a mind over matter, positivity, it marshals all my body's resources and I just fight that infection and take it out because of that just positive attitude. And there's some studies on the effect of that. Or maybe I think the symptoms have gotten better and I report that they've gotten better because that's what I believe. Whether or not they are is another story. So one person, again, it could be one person experiencing the randomness of life. Or you could have the one person who's just, they're not going to react to this thing at all, even though if you gave it to 99 other people, you would see an improvement in flu symptoms. So you want to make sure your group is big enough that you can actually see the change. You don't have like one person or a couple people or 3 or 4 people that by random chance they all did well, or by random chance nothing changed. But again, if you added more people over this larger group, you would see a tendency to improvement or maybe a tendency to nothing. So you want to make sure your sample size is big enough. All right. So the size, make sure you've got a big enough sample. And of course, we always wish we had the entire population to test, but as we've mentioned in the past, that's usually not possible. As far as I know, it's completely impossible. Well, it depends on what population you're looking at. All right, so that's one thing. The other one, called blinding. Your subjects do not know if they're receiving the treatment or the placebo. And commonly when you're doing this, you're letting everyone think they're getting something. You're just giving them a pill. You might tell them they're getting the treatment. Again, whether that's ethical or not is another story. But you're all giving them a pill. Let's say we're doing that. You don't want to tell someone that they're not getting the treatment if you're trying to test, say, for whether a drug works. Because if they know they're not getting the treatment, that's going might affect that placebo effect, and you might not get the full placebo effect. So, and that's, you know, placebo effects sort of part of the randomness of life. So we typically don't let subjects know that they're getting one or the other. You just get a pill, and we're going to see what this pill does. And at some point, we'll know, maybe if not specifically, but we'll know if you have improvements and then no improvement, which of the improvement people had the drug and which ones had the placebo. We'll know that at some point. But we don't let people know if they're getting the treatment or the placebo. And one reason you might do that is, again, you know, if you tell people, look, this isn't going to do anything, it's just forget about it, that might, you know, that might invalidate the study to some degree. Your placebo effect might not appear. And so the idea is that we want to see, is this drug more effective than just, say, positive thinking? I mean, if maybe it's not. And if that's the case, then, well, we don't need to give people this drug. We just need to, well, get them to do positive thinking. So, well, there you go. So we want to have blinding so our subjects don't know if they're getting the treatment or the placebo. Now, there's something called a double-blind experiment, and this is big. In this case, the subjects and the researchers don't know who got a treatment or who got a placebo. An example of this, why this is important, is let's say you have somebody handing out treatment pill, placebo pill. They look the same, but they have this sort of like barrier, and they can see the treatment pill and the placebo pill. The subject can't see over the barrier. So they pick a pill and they hand it to the subject. And then they write something down. Subject, have like, say the subject has a little like number tag on, instead of a name tag with a name, it's maybe some numbers and letters. And they say 4A62Z, that came from the left side, that's a treatment. Next person comes along, it's P326F. And they write it down. Pill comes out, it's the placebo, it kind of came from the right stack, they give it to them. All right, fair enough. The subjects don't know what kind of pill they're getting, but maybe the researcher kind of gives it away. Like the subject walks up and the pill pops up and it came from the left side of the little box on the left, and you know that's the treatment. Oh, here you go. This will probably make you feel better. And then next subject comes up, pill pops up, came from the box on the right. And it's the sugar pill, like, yeah, there you go. You might show or alert or influence the subject that they're taking a treatment or a placebo. You could do that accidentally. And again, we want to test, does this drug work better than, say, positive feelings? So if everyone knows they're getting the placebo because the researcher can't keep a straight face, well, then they're going to know that this isn't going to do them any good. They're not going to get that positive feeling. And you're not going to be able to test whether positive feelings are more effective than your drug. Hopefully your drug is more effective if it's supposed to make things better, get rid of these flu symptoms. So we do a double-blind test where researchers and subjects, they don't know who's getting the treatment. In that case, you would have a researcher who, there's numbers on the pills, and there's no sense to it. They're just random. The pills are given random numbers. Somebody off to the side recorded the random numbers for those pills and knows that that number means it's a treatment pill. But this number, this is a placebo. This number is a treatment. This number is a placebo. And that person's just off someplace else. But the person handing out the pills, they just have a box of pills with numbers on them. They have no idea what these numbers mean. They just hand a pill to a subject. They have their little identification tag on there. So they just put the tag, the pill number, and then they'll hand that off to someone else. And so that's double blind. All right. So a very powerful method. So we want to make sure our sample size is big enough so we can see the effects, hopefully more accurately. We want to make sure we're not influencing our subjects by letting them know if it's a treatment or a placebo, say, and maybe that has some effect on people's reactions in the experiment. You also sometimes want to make sure the researchers don't give it away, or they might show some kind of bias, and that could throw off the results. So there, sometimes you want the person giving the treatment to not know which treatment they're giving, as well as the person receiving it. So, and again, this is usually cleared through like an ethics committee, and people are aware that this is what's going on. So just letting you know. Again, you want to always clear these with like ethics committees and things like that. All right. So another element of experiments, randomization. So individuals, assigned to groups randomly. And the idea, the goal here is you want the two groups to be similar through chance. Now, why do you want to do this? Well, first off, why randomly? Well, let's go back to our flu symptoms. Let's say you have a group of people who've been training for like the, I don't know, some track and field event, the Iron Man or the Iron Woman or something like this. It's like we're just going at it. An Iron Person. And you're just going to train and train. It's running, it's swimming. Gosh, what else? Bicycling. And you're just going. You're just super healthy. And you're doing this, or maybe you're doing some other event where you're just building your cardio up. You're just charging whatever it is. This event, you've been training for it for, say, 3 months, maybe 6 months, maybe a year. And you're all fit. And when you get this flu or these flu symptoms, because this study sent a call out, hey, if you have flu, come to this study. We want to see if we can do something about those symptoms. So you're training and yeah, you kind of get a flu and you show up and you're pretty fit. And so what happens if they do this study is they get a whole bunch of people who are fairly fit, and it turns out that this happens to be a benefit to this particular strain of flu, where the symptoms don't get you as much. But then you have another group of people, or you know what, I did my physical event maybe 3 weeks ago. I haven't been training. Maybe it was 3 years ago. We're just not my thing. I don't do that kind of thing. I do other challenging things, but not, physical things. And it turns out this kind of flu kind of gets you if you don't have that way above average cardiac output or something. And so let's say you decide to have the group that is going to get this treatment. These are people who have that high fitness, and that just so happens for this strain of flu tends to minimize the symptoms anyway. They have a group of people where physical fitness, it's not as big a priority. We do other things, maybe it's authors and artists and musicians and things like this. And okay, we do our thing, we have our challenges, but it doesn't involve physical fitness. And this particular strain of flu is going to hit us a little harder. So when you hand out the treatment group their treatments, placebo group their placebos, and yeah, we might not know which one we're receiving, but the people who put the study together, they know these people who have all this exercise, they're getting the treatment. Us who aren't exercising, we're getting the sugar pills. Well, is this a valid study to see if this treatment reduces symptoms by comparing, how each group feels? Probably not. So, or at least it could seem questionable. I mean, the drug might still work anyway, but, people might have some doubts about this study. So you want to mix this up. You want to make sure everyone's mixed up. You have two groups that are pretty much the same. Roughly same numbers of physically fit people, same numbers of people who aren't doing that kind of training in both your treatment group and your placebo group. And then test your treatment, then administer your placebos. So you want to do this randomly. You pick people, you assign them randomly. And also, again, you don't want to, give it away which treatment or if you're getting a placebo. And then also, again, you want the groups to be roughly similar. So we're going to see how this treatment affects people versus when the people are receiving the placebo. So we want to assign these groups randomly. All right. Now, we talked about a gold standard. And ultimately, where we're going with this is something called the simple random sample. And you're going to hear this a lot. And it's abbreviated SRS. And the simple random sample works like this. You choose n, some whole number n, subjects. In a way, we're going to get into some details of how to do this, but in a way, so any group of size n has same chance of being chosen. There's a slight subtlety here. But if you have a group of n subjects, so you have a group of n people, say, n people, then you choose them using some method, some way. So any group of size n, whatever any other possible group could be, has the same chance of being chosen as the group that you ended up with. So that's the idea of a simple random sample. You come up with some method to choose n people, and any other group of n people, there was an equally likely chance of choosing that other group. So that's our simple random sample. Now, this is a little different from what's called a random sample. And in the text, they mention that they sort of use the terms interchangeably, but this is what the text has. In a random sample, let's see, each member of the population has the same chance of being chosen. Same chance of being chosen for the sample. So this is what the text calls random sample versus a simple random sample, where you have a group of n people, and well, that group versus, well, any other group of n people, the same probability of picking, say, one group or the other. Anyway. Now, this way that I put in quotes earlier, this is going to be hard. This is sort of ultimately the heart and soul of this chapter. How do we do this? And we'll get into a little of that soon. So the thing here, to find the way, it takes careful planning. We're going to look at that next time. what some of this careful planning is. And sometimes it's not just one step that you do. You might have to do multiple things to come up with, well, a way that's going to get you at least close to being a simple random sample. The moral of the story here, this is the text, randomness needs help. Randomness is going to need help. All right, well, that's the first part of section 1-3. If any questions, let me know. Other than that, have a wonderful evening.